All right, here we got a couple of example problems, dimensional analysis. The first two are a little more basic, and you're going to use them a lot more frequently in chemistry. This is something we're all familiar with, but we're not really going to use it in the course. It's just to get a better idea of how dimensional analysis works. So we're going to start with the first one. We have 4 liters of Cl2. That's the amount that's given to us. What we want to eventually get is how many milliliters of Cl2 gas does this equal? And I apologize, my handwriting is a little difficult to read. You always put this value over 1, always, always, always. You also always label your units, liters of chlorine gas, or Cl2. As of right now, it's not terribly important to label Cl2 because we're just converting from one number to another. But in the future, when we're looking at chemical reactions, we need to make sure we label every single thing. What is the compound or element that we're looking at the moment? So that's going to be what's given. The next, you're going to have your conversion factors. The rest of the problem for any dimensional analysis is always going to be conversion factors. Whatever is on the top needs to equal whatever is on the bottom. It's the same concept as multiplying a fraction by 4 over 4 or 10 over 10, just to get an equivalent number as your answer, but maybe with a different denominator. In this circumstance, the number on the top is going to equal the number on the bottom of the conversion factor because in a sense you're multiplying by 1. You're just changing the unit of measurement. So the value, however much you actually have in real life, is going to be the same. So the next step, we see liters on top. In a fraction, if you have a number or a value on top and you have that same number or value on the bottom of another fraction, they cancel out. And that's what we want to do. We don't want liters anymore. We want to get milliliters, and we can convert from liters to milliliters. So that's what this conversion factor is going to be. There are 1,000 milliliters in 1 liter. So these two values are equal to each other. It may not look like it, but it's because they have different units of measurement that they are equal. So the liters ends up canceling out. And I'm going to write the answer down here because I want to use a correct number of sig figs. So I haven't covered sig fig rules yet, but that's going to be in one of the next videos. So we end up getting 4 times 1,000, which is 4,000. And that's going to be milliliters of chlorine gas. Now, in the original problem, we have 2 sig figs because our decimal is present. So we start from the left-hand side and we count all the way to the end. So we need to change this so that we also have only 2 sig figs. So right here, technically we have 1. And the only way to get the correct amount of sig figs is to add a decimal. We can't add the decimal to the very end because that increases the number of sig figs to 4. So what I recommend we do is we write this as 4.0 times 10 to the third. That way our final answer has the same number of sig figs as our original question, plus we have 4 times 10 to the power of third milliliters of chlorine gas equals 4 liters. So we're going to do that in the rest of the problems as well. We're going to make sure we have the correct amount of sig figs. And we can even go ahead and say this question right here has 3 sig figs. And so does this question, has 3 sig figs. So that's what we'll make sure that we have in our final answer. So the next problem, we start off with our given, just like before. So we have 0.0103. There we go. It's kind of difficult to write on here, so bear with me, please. Grams of potassium, so K is potassium. We need to get rid of grams. We don't want grams anymore, so we're going to put grams of potassium on the bottom. And we need to convert to milligrams, which is pretty simple to do. It's pretty much the same thing that we did in the previous problem, except instead of going from liters to milliliters, it's grams to milligrams. But it's still going to be the same thing because there are 1,000 millis in your standard unit. So 1,000 milligrams in 1 kilogram. So when we multiply these, we end up with 10.3 milligrams of potassium. That's what we get when we cancel out our grams and we multiply this number by 1,000. So we're multiplying the two numerators. Technically, this has the correct number of sig figs, so we can just leave that alone. We don't have to change that like we changed the previous problem. Actually, I already have my units of measurement written there, so I'm good to just write that number. All right, now the final example, it is a little bit more tricky, but it deals with something a little more tangible that you guys can understand a little bit better. So we're starting off with miles, and we're going to figure out how many inches are in 0.125 miles. So we're going to start with what's given, 0.125 miles. And we can't really go straight from miles to inches. At least I can't. I don't know exactly how many inches are in a mile. And if I don't know that conversion factor, I can't use it. But I do know how many feet are in a mile. And then I do know how many inches are in a foot. So I'm going to use that to get my final answer. So everything that we're multiplying by, they're going to be equal to each other on the top and the bottom. This is the same thing as multiplying by 1. So if miles is on the top, I want to cancel it out and put miles on the bottom. And I said I can't go from miles to inches. I don't know that one off the top of my head, but I do know miles to feet. So I'm going to go from miles to feet. There are 5,280 feet in 1 mile. These two values are equal to each other. It's the same thing as dividing 5 by 5. It equals 1. So this many feet equals this many miles. It's just different units. That's why you're allowed to have different numbers, because they're both equal. And then I don't have to worry about miles anymore. Miles cancels out. Feet is on top. I need to go from feet to inches. So in order to get rid of the feet, I'm going to put the feet on the bottom and then the inches on the top. And I do know there are 12 inches in 1 foot. So these two values are equal to each other. So this is the equivalent of multiplying by 1. So I'm going to cancel out my feet. My final answer will be in inches. And for this, I'm actually going to have to use my calculator. So I'm going to have to plug this in. So 0.125 times 5,280 times 12. I get a rather large amount simply because inches are super small and miles are rather large by comparison. I get 7,920 inches. Now I want to think about this for a moment. In my original question, I know I have 3 sig figs. In this problem, I don't have a decimal present because I ended up with a whole number. Don't really need to put a decimal there. So because a decimal is absent, I'm going to start from the right-hand side and count inwards starting at the first non-zero number. Technically, I got 3 sig figs here too, so that works out really nice. I don't have to go back and change my answer. I'll be coming out with some more videos on dimensional analysis, but the next videos I'm going to come out with are going to incorporate Avogadro's number and the mole. So that way we'll get some actual chemistry practice with those.